Today we'll be starting a new unit on probability. This first lesson is just an introduction to probability, so our notes start off with some definitions. I'm sure you're familiar with a lot of these words already, so we have probability, outcome, event, and a sample space is just the set of all possible outcomes. So the first thing I want to do is fill in the basic definition of probability. Probability is equal to the number of successes over the total possible outcomes. And probability could be written three different ways. So we could write it as a decimal or as a fraction, and these have to be numbers between 0 and 1, or a percentage between 0% and 100%. So if we have a probability of 0, that means the event has no chance of occurring, it's totally impossible. And a probability of 1 means the event will definitely occur. So on this second page, we're going to start with theoretical probability. This is when we calculate the mathematical likelihood that an event will occur. So we don't need to actually run the experiment. We already know the number of outcomes in the sample of space and what this experiment would look like without actually doing it. So if you look at the first example, we're talking about tossing a coin and rolling a single-sided die. So we don't need to sit there and actually do this. We know what the outcomes would be. So part A wants us to write a set of ordered pairs such as H4 that represents all outcomes for this experiment. So in this case, the H, 4 would represent heads up and rolling a 4. So this is called a sample space, since we're writing out all of the outcomes. We usually call this set S. So I can start with landing heads up on my coin. And I can land heads up and roll the die and get a 1, heads up and get a 2, and so on until I get to 6. Since I have 6 different sides on my die. So we can land heads up 1 through 6, and I can repeat this with tails 1 through 6. Okay, so there's our sample space. Then part B says to circle the set of ordered pairs that represents the event of getting a tail and an even number. So if I look back at my sample space, I'm going to circle tails and an even number, and we're going to call this set A. So part C says to find the probability of A. So if we look how many items we have circled here, that's 3 out of our total possible outcomes is 12. And we could simplify this to be 1/4 or 0.25 or 25%. So remember, we can really write probability any of these ways. Part D says the complement of set A will be all events in the sample space that do not fall into set A. So that's kind of like everything else that is not circled in part A. So we're going to call this set B. The probability of set B occurring would be everything that's not circled. So that's 9 out of 12, which simplifies to 3/4 or 0.75, 75%. And now part E says to find the probability of A plus the probability of B. So if I add our two parts together, part C and part D, I'm going to get 0.25 plus 0.75, which equals 1. Now there's a few notes at the bottom of the page. So a set and its complement are important because all outcomes either fall into an event or its complement, but not both. So when we looked at part A, I'm either in that circled area of set A or I'm in everything that's not circled set B. And it's important to note that the probability of complements will always add to 1, like we saw in part E. All right, and moving on to exercise 2, now we have empirical probability. So this is when I have to actually use an observation, use an experiment to figure out the possibilities that it could occur. Exercise 2 gives me a survey done by a marketing company to determine which of the 3 sodas was preferred by people. So this is different than what we just did in exercise number 1 because I need this table on the right-hand side in order to answer the questions. So the probability that a person selected at random from this group would prefer soda B is going to be 24. out of the total 53. Remember, we could write this as a decimal or as a percentage. I just don't think this rounds to a nice number. And for part B, find the empirical probability that a person selected at random from this group would not prefer soda A. So I could either add up soda B and soda C, or just take the total, 53, and subtract the people who like soda A and get 35. So people who do not prefer soda A would be 35 out of 53. All right, and then the last thing I want to talk about is sets. So we already discussed a sample space is all of our possible outcomes. We can kind of organize the sample space using sets. So a set is simply a collection of things, and the things that are in the set are called elements. So you'll hear those two words a lot this unit. Exercise 3 tells us to consider rolling a single six-sided die and record the results. A is the event of rolling a number greater than 4, and B is the complement of set A. So when you see this word complement, if you want to make a note, if it's the complement of set A, that just means it's not A. So we're going to include everything except what we included in set A. So we can use our Venn diagram and fill in set A are the numbers greater than 4, which would be 5 and 6. So B is going to be not A. So everything else on the die besides 5 and 6 would give us 1, 2, 3, 4. Now part B says find the probability of A and the probability of B. So P of A is 2 in our circle over there out of the total 6, which is equal to 1/3. And the probability of event B occurring would be 4 out of 6, which simplifies to 2/3. And then part C says what's the true sum of P of A and P of B. So if I add these together, 1/3 plus 2/3 is equal to 3/3, or 1. And this makes sense what we talked about on the page before. Since they're complements of one another, we know that their sum has to equal 1. Oop. All right, and this last example I'll go through. So example 4 has all of the integers from 1 to 10 in their sample space. We want A to be the set of all integers that are even. So we can make a note here. A is going to be the even integers, and B is going to be all integers that are multiples of 3. So we can first start by filling in our Venn diagram. So in A, our even numbers are going to be 2, 4. Now 6 is an even number that's also a multiple of 3, so we could put that in the overlapping region since the two sets there will share that. And then we have 8 and 10. And our multiples of 3 are 3, 6 we already took care of, and 9. The last thing you want to do for these problems is make sure you're including everything in the sample space. So if we look back to where we started, there's some numbers that we didn't include, and we're just going to put them in the rectangle on the outside and not in the circle so that they're still in the sample space. So on the outside, we should have 1, 5, and 7. And that should be everything. Then it says to find the following. So this n of A, when we see that n, that just means the number of elements. So n of A is asking us what's the number of elements in set A? When we're answering that, we don't just want to look at the 2, 4, and 6. We want to look at this whole circle because that represents A. So the number of elements in set A is 5, and the number of elements in set B, this whole circle here, is 3. And then our next part says, why is the following equation not true? So the number of elements in our whole sample space, we know this is integers from 1 to 10. So we have 10 elements in the sample space, is not equal to 5 plus 3, right? 10 is not equal to 8. And why is that true? Well, there are some elements in both sets, in both A and B, right? The number 6, and some in neither. Like on the outside, we had 5, 7, and 1. So our sets A and B don't really represent the entire sample space. Then this last box here has another definition. So to be mutually exclusive, two events cannot share any overlapping elements and cannot happen at the same time. So if we look back at this example, this would not be mutually exclusive because we do have an element in that overlapping area. If that middle area was blank and there was no 6 there, then maybe this situation would be mutually exclusive. All right, and now we're up to the 2 practice problems. So if you guys want to take a second, finish these 2 problems, and then submit all of your notes on Canvas.